Hi everyone, hope you are doing good. Thanks for joining the session. So here I am going to discuss about descriptive statistics of Python. Give me 1 second. Yep. So I'm taking this information from real Python. Python statistics fundamentals and how to describe your data. Describing the data is most important part of the data. It's like initial step of the data. EDA, exploratory data analysis. It is even called as exploratory data analysis. Okay. So the table of the contents or the follows. Understanding descriptive statistics. So trying to understand what is the importance of descriptive statistics. Types of measures. What is population and what is sample. Outliers. So what are these outliers and what is the importance of these outliers with respect to different industries? And choosing the Python statistics libraries. So there are various libraries in the statistics, but what is the best statistics library to be chosen? Getting started with these libraries, calculating descriptive statistics, measures of central tendency, variability, summary of descriptive statistics, measures of correlation between pairs of data, working with 2D data, access data frames, visualizing data. So some plots like box plot, histograms, pie chart, bar chart, XY plots, heat maps, and the conclusion. Okay. So in the era of data science, big data, AI, data science, machine learning have become an important essential in many fields of science and technology. A necessary aspect of the working with data is the ability to describe. So data has become most important in our day-to-day lives. Analyzing it, trying to describe, summarizing, representing the data visually is the most important and the need of the hour. Python statistics libraries are comprehensive, popular, widely used tools that will assist you in working with the data. Yeah, Python has varied libraries, so we will understand few of the most important libraries in this tutorial. Okay, in this tutorial, we'll be covering like what are the numerical quantities you can use to describe, summarize your data, how to calculate descriptive statistics in pure Python, how to get descriptive statistics with available Python libraries, how to visualize your data. So let us try to understand what is this descriptive statistics. So it describes about the data in a simple sense and summarizes the data. It uses two main approaches, the quantitative approach and the visual approach. Quantitative approach describes and summarizes the data numerically. It says like the mean, median, mode, range. The data ranges from 0 to 100. Mean is something like the average of the numbers. Mode is the most commonly repeated number in the data. Visual approach. So coming to the visual approach, it represents the data in some charts, plots, graphically representation. You can apply descriptive statistics to one or many datasets or variables. When you describe and summarize a single variable, so whenever you're performing this analysis for single variable, we call it as univariate analysis. When you search for some statistical relationship among the pairs of variables, if you're doing a pair of a variable, it's of comparing two variables, it's called a bivariate analysis. Similarly, multivariate analysis is concerned with multi-variable at once. So if you're considering multiple variables, more than two are called as multivariate analysis. Okay. Types of the measures. What are the different types we have? Okay. So here we are going to cover about the central tendency, variability, correlation, or joint variability. So, what does this central tendency? This will tell about the centers of the data. So, what are the different types of the centers? Uh, so, earlier I've said you about mean, median, mode. These are the useful measures for our central tendency. Variability. Variability tells you about the spread of the data, how far the data is spread. Useful information include variance and standard deviation. We might have read or practiced these concepts such as mean, median, and variability, variance, standard deviation during our schooling days. These are the same concepts which we discussed then earlier, but we are really using them in our day-to-day life to analyze the data, the numerical data. Correlation tells us the relationship between a pair of variables in the data. I can give you an example like in summer, purchase of ACs will increase. This example is concerned to India. In India, purchase of ACs increases during summer. During winter, purchase of woolen clothes increases. If a textile shop doesn't have woolen clothes or sweat jackets, they'll not do good in their business. Useful measures include covariance and correlation coefficient. So what does this correlation coefficient will say? This gives a number between -1 to +1. This gives the magnitude and direction. If it is positive, if the correlation coefficient is positive and the number is closer to 1, this shows the highest collinearity, highest correlation between those two variables. If it is of negative value, then there is a negative correlation. They are inversely proportional. You can say it as inversely proportional. You learn how to understand and calculate these measures with Python. So some pretty much required concepts, but in course of time we will learn in Python. So this is very much popular, which we frequently hear as population sample. In statistics, population is a set of all elements. Sample is a subset of the population. So coming to the description here, population is set of all elements or element in items that you're interested in. Population are often vast, which makes them inappropriate for collecting and analyzing data. That's why statisticians usually try to make some conclusions about the population by choosing and examining a representative subset of that population. Basically, we don't analyze whole data. We analyze the data, we analyze the subset of the population that is called as sample. Ideally, sample should preserve the essential statistical features of the population to a satisfactory extent. So, my sample should represent my population. My sample is small in number when compared with the population. Why? Because that will really help me to analyze the data in easy manner. That's why you're able to use the sample to glean conclusions about the population. So coming to the outliers. Outliers are pretty much important in financial domain. You might hear this example like credit card fraud. So outlier plays an important role there. An outlier in the data point that differs significantly from the majority of the data taken from the sample of the population. So it's a data point. It differs significantly, means importantly from the rest of the data, from the rest of the majority of the data. There are many possible causes of the outliers. So there are many causes. You can causes of this outlier, but here are few to start off. Natural variation in the data, change in the behavior of the observed system, error in data collection. So there might be a natural variation in the data, natural cause, or there might be a change in the behavior of that particular system. Error also might be there. Data collection errors are particularly prominent cause of outliers. So he's saying like collecting the data, errors in data collection or the possible cause of these outliers. For example, limitations of measurement instruments or procedures can mean that correct data is simply not obtained. Limitations of measurement instruments or procedures can mean that the correct data is simply not obtainable. Other errors can be caused by miscalculations, data contamination, human errors, and more. There isn't it a precise mathematical definition of outliers. You have to rely on experience, knowledge about the subject of interest, and common sense to determine if data point is an outlier or and how to handle it. So I'll be continuing the rest of the topics in the next of my tutorial. Looking forward to speak with you. Thank you. Have a good one.